Do I still need that? Do you still need it? I only have few guys. It's okay. Anyway, I think I have a clicker here. So no pre-lunch. Okay, let's talk about creating your own customized metamorphic algorithm. I actually just revised this the last part I came from ShowMeCon just a few days ago. I showed something like similar to this one. Okay, about me, some of you knows that if you're reading articles from Virus Bulletin, I published like 22 articles, like in a span of like 5 years, 6 years. And I work at Fortinet. Okay, those are some of my conferences the conferences that I've been to already. And most of the time I send this picture as my bio picture. But actually, this is like me when I do malware research and analysis. Anyway, okay, we're going to talk about Birlac, which is a file infecting ransomware. Some of the features that we can see, the reversing stages, and then we'll try to how to make our own customized version of its Metamorphic Engine. Okay, Birlac is, let's talk about file infector. When we talk about file infector, it is actually, it attaches the malware code to a file, to a host file. Like, for example, it wants to infect calculator, it will be infected. Then when you run calculator, it will again look for another host to infect. Okay, most of the time, it is one of the malware that is hard to restore, because if your calculator is infected, it's okay, just delete the calculator and restore the Windows system. But if you are developing some executables, some applications, it is infected, then it is very hard to clean. Sometimes it might corrupt your apps. And ransomware, as we already know, but this one is not about WannaCry. Okay, I don't have time to do that for a presentation. But when we talk about ransomware, sometimes, most of the time, it encrypts your files, and then, of course, if you want to pay, you have to pay with Bitcoin and use Tor and everything. So that's the reason why ransomware is in a boom industry now, because the criminals can get away with it because of the Tor and Bitcoin payment. Okay, Birlac is a combination of a ransomware and a file infector. That is why it is somehow a bit complicated to analyze. Okay, if you are infected with a ransomware and then you were able to clean it, okay, you're fine. But if it is infected, okay, you somehow you somehow back up your infected copy. You thought that it's already fine. When you run again your applications, you will get infected again. Okay, that's one of the stronghold of the Birlac for the file infector. As a ransomware, some of the visible symptoms. The good thing with a ransomware is you will know if you are infected or not. Unlike a regular file infector, unlike other Trojans, worms, you'll never know. For ransomware, you will always have a visible symptoms like that. If you're going to do some presentation, and if you're infected with ransomware, and then your presentation is already done. Okay. Good thing, it's just part of the slides. Okay, if you're infected with Birlac, okay, it knows where you are. It knows your location. I live in Vancouver, so it knows that I live in Canada. If you click that, if you run Birlac in US, it will change this flag, and then it will change this amount here, 250 USD. Okay, not 250 CAD, it's Canadian. And of course, another good thing, okay, I'm not saying that ransomware is good. Another good thing with ransomware is, if you don't know, if you're infected and you have nothing to do, or you don't know about anything about Bitcoin, okay, it will teach you what is Bitcoin. It will explain everything. Okay, it will explain what is Bitcoin. And then if for example, your grandmother was infected, and then she will panic and everything, but, okay, at least she will know what is Bitcoin. You don't need to explain it to her. And the thing is, you already know the Bitcoin, but where can we get the Bitcoin? Can we go to the bank? Can we go somewhere else? Beer Luck will show you locations wherein you can actually get the Bitcoins. In US and Canada, you can actually go to a place wherein you can see something like that looks like an ATM machine. Okay, wherein you can actually exchange your cash to a Bitcoin number. It will just give you a printout and with the Bitcoin. Actually went to Seattle one time, Seattle to Lailip. Okay, wherein there is a machine there. I'm supposed to get a video, change my money to Bitcoin. The problem is, okay, because that machine is a legal entity, okay, they need my license number to purchase a Bitcoin. So I did not do that. So no demo for the Bitcoin. And then, because it doesn't actually know where you are exactly in Canada, or probably if you're infected in US, it will give you some locations that you are probably, for example, if you are in Vancouver, there are 3 locations that you can get your money. It is very helpful. The problem with Beer Luck is if you're infected, you cannot really go somewhere else inside your computer. Okay? It is locking. It is one of the category of ransomware that locks your computer screen too, unless you pay. Okay? If you're rich and have an extra money to pay, okay, you can go look for the particular amount for the Bitcoin itself. Anyway, that is the visible symptoms for Beer Luck. As a common malware, normally when we analyze a malware, not only ransomware, we use some tools. The debugger, this is if you want to go deeper in the code. Okay, so I normally use Immunity Debugger. I usually prefer this because you can use Python script to automate your debugging. But if you encounter 64-bit malware, okay, you can use x64dbg. Another good thing with 64dbg is it is always being enhanced. They always have updates and everything. Okay. Okay, for common reversing, normally if you have encountered a pack or encrypted malware or infected file, okay, usually you try to unpack the malware and then you can see this. Then you can use the decrypted or unpacked version to do static or dynamic analysis. You can use IDA or you can dump it to some disassembler and so on. Okay, but this malware has different stages. The first one, when you get an infected file, okay, you only have this is your MZ header, and you only have 2 sections, the .text and the .rsrc, the resource, okay. Afterwards, from that text, actually somewhere down here is your metamorphic algorithm. This is the metamorphic code, okay. When you run the metamorphic code, it will actually decode a few bytes at the top of the file, okay, before, of course, after the header, okay, and then that decoded bytes are responsible for creating the main function, wherein the main function is the one that is responsible for the on-demand polymorphic. So Beer Luck has metamorphic, it also has metamorphic. The problem with this one, I call it the on-demand polymorphic because, okay, when you try to run as one function, okay, it will try to decrypt that function, execute the function, and encrypt it back. But the problem is when it encrypts it back, it uses a different key. Okay, that's why I call it on demand. Okay, and unlike other malware, when you try to unpack it in memory, you can just grab it and dump it. But this one, you can only see at any given time, you can only see a decrypted one sub-function. That means every time you execute a function, for example, there's a function that drops a file, okay? And then when it encrypts it back, it is now different. So that means from the original code earlier, it goes to memory, it executed several functions already, it will look like Christmas lights inside your memory because it's different. If you run it again, for example, you try to run it again as in a different system, it will give you a different set of binaries. That's why I call it on-demand polymorphic. And at the end, you can actually see the host file somewhere here. Okay. The good thing with that is the host file, when it is only encrypted using an XOR. You can easily clean your file, okay, by using just a regular XOR decryption. Let's look at now as the BeerLac as a file infector. Okay, as I've said earlier, it is encrypted, but all you have to do is to locate the proper location of that malware and then look for the decryption key and use a simple XOR, something like this. Okay. Initially, you will see encrypted version. Okay, running this code, it will actually generate, okay, look for the decryption key, run that one. You can actually create a Python script in order for it to decrypt. Okay, when it is decrypted, okay, from the same memory location, it is actually gonna give you the name of the original file, the executable, and this is now your, okay, if you're familiar with the executable structure, this is now your decrypted version. Okay, look at this, same location, but this one is the decrypted, and the other one is the encrypted host file. All you have to do if you are in charge of the cleaning part, create a Python script, look for the keys, decrypt, and then that's it. That is for the file infect. For polymorphic malware, as a polymorphic malware for BeerLac, okay, we're going to, it usually uses a decryptor with that old key. Okay, it uses some garbage code, redundancy, it uses XOR to generate the key. Okay, these are the garbage code, wherein when we talk of garbage code, that means they are irrelevant to the code. Okay, you have to do, that means it is used for like, for the analyst, for them to take longer for analysis. Then while the researcher is looking into the code, the malware is actually going around globally, and then probably once the researcher is done analyzing the malware is also done infecting the whole world. Okay, so that is the purpose of usually the garbage code. Okay, just to slow down the research. And then this one generates the key. It decrypts the function, and then it executes the function. This is the actual XOR decryptor, and then afterwards, it runs the execution. So it executes the newly decrypted code, and then it uses the RDTSC function. It gets the timestamp, okay, on that particular one for it to generate a new key. To generate the new key, all you have to do is to use the RDTST, save it somewhere, and then use the key bytes, and now it XOR backs. It uses the same code. Okay, this one. This is the same actually code in order for it to regenerate a new key every time. That is now where the new key is. Or if you're going to look at the decryptor, this is the decryptor. This is the key actually. And then after getting that, it will show you that everything is the same except for this one is the old and the new key. So that is how it generates the new one. And then it uses the same decryptor, wherein it uses all that particular, it goes back. Because it's only an XOR. If you XOR something with the same thing, it gives you the same value, the original value. And then it gets another. For example, this is the code encrypted with an old key. Okay, I just grabbed the 16 bytes. After decrypting, it will look like this. This is the decrypted code. This is actually now the executable portion of the malware. And then after executing that one, it will generate the key. Okay. It is now encrypting it with the new key. Look at this. They are all in similar location. If you go to your memory, if you try to access your memory process, you will only see this particular one as decrypted. Other else are also encrypted. So you cannot dump totally the whole thing. If you want to dump the malware, you have to dump it, follow the code, follow the decryption. If it is decrypted already, dump it, that particular portion, try to decrypt the other part, and then you probably can be able to get the whole malware process. For detection, if you are in charge of if you want to try to detect the malware, okay, do not get this particular part, because this one is encrypted with old key, this one is encrypted with the new key. They always change, but this one doesn't change. They always have the same decrypted version. Okay, so if you want to make detection for that particular malware. For the part of the code, okay, sometimes this one is also changing. Okay, all you have to do is to detect the one wherein it loops to generate the new key. That is for the detection. Let's go now to the main part, metamorphic algorithm. When we talk about metamorphic algorithm, what is the difference between metamorphic and polymorphic? Polymorphic is it changes the code, at the same time it is encrypted. Okay, that is polymorphic. For metamorphic, it changes the code, but the code itself is not encrypted. You can actually totally see, you can actually read, or you can use IDA or disassembler in order to see the code. But the thing is, there are many ways to generate instructions that is actually doing the same thing. Like, for example, this one. If we are trying to put a value 0 to a register EAX, you can use mob EAX 0. You can use XOR. It generates also a value 0 for EAX. Or you can, of course, subtract the same value to that particular register. It also generates 0. Or you can combine different instructions, but at the end, it will generate a 0 for the EAX. That is what we call metamorphic. Different group of instructions, but it produces the same result. Okay, but encrypted, you cannot actually run the encrypted bytes, the polymorphic, right? Because it is encrypted. But for metamorphic, you can run the actual code, but they are different, compares to different samples. That is metamorphic. Most of the time, it is hard to find similar bytes if you're looking at the detection. For BeardLock, it uses different length of bytes just to generate the 4 bytes, different 4 bytes. Okay, let's look at the Metamorphic engine for BeardLock. Okay, it uses different number of instructions. Registers used per instruction. It changes EAX, EBX, and so on and so forth. And then it has its own instruction generator, generator 2, then length of code to encode. If you're going to look at, this one is in IDA. Okay, this particular part is the pseudo value generator. Okay, it generates a certain amount of different value in order to select which registers are you going to use. Okay, ESI contains the buffer of the actual where you are going to put the decrypted version or the encrypted version, and then this is the EDI contains the malware buffer. This one generates which register is to be used for the address, which registers to be used for the code. Okay, so this particular part of code will generate those different information that the malware needs. So different ingredients to create the Metamorphic engine. Okay, this one is the instruction generator 1, wherein it depends on the combination of EAX, EDI, EBX. Okay, it will generate the mob instruction. The mob instruction for the code register, address register. Okay, sometimes if it is EAX is 0, EDI is 2, EBX is 1, or -1, compared to this, it now generates, instead of mob, just regular mob, it generates the sub, and so on and so forth. Okay, it depends on the different combinations of the registers. Okay, so sub or add and everything. Okay, and this one is different groups of combinations of those registers. And within the BeardLock malware, it has a table wherein it decides. This is where it decides. So it creates a pseudo random value and then checks the table, and then it decides, am I going to use an add instruction, a sub instruction, or just a regular mob instruction. And then the second random generator is the one that creates the instruction wherein it puts the generated value to a certain register. I have here a demo, not live demo, just a video demo okay, just to make sure that everything is going to work. this is how it generates the metamorphic algorithm. So it gets the timestamp, okay, creates a pseudorandom value from the timestamp. It is now going to generate a certain instruction from the generated pseudorandom value. So looking at this, it is actually going to generate an instruction just to encrypt 4 bytes, a D word. Calling the instruction 1 function. See, you can see it generates either, it depends on the part wherein it generates the mob, the sub, and then it will encrypt this malware code, just the 4 bytes. Okay, that is how it generates the metamorphic algorithm. Now, so with this code, okay, if you run this, it will decrypt the 4 bytes here, and then another group of instructions will generate or will encrypt another set of 4 bytes. It will continue to do that. That is what we call the metamorphic algorithm. Look at this particular part. Okay, earlier it only generates 5 instructions, but this one it generates a few more than 10 instructions just to encrypt that particular 4 bytes. So it depends. So that's the reason why it is sometimes hard to detect. You cannot just look for the number of instructions to generate the 4 instructions, to encrypt the 4 instructions. That means, okay, you cannot really follow this particular part in order for you to detect the malware. Okay, it will go on to, it will make these instructions as long as there's still bytes and codes to encrypt on this particular part. It will encrypt that particular metamorphic algorithm block of code. And afterwards, after generating the metamorphic algorithm, okay, so this one, it generates, the code, in the demo that you've seen earlier it just generates this. Okay, this particular part. Okay, most of the time, okay, if you're going to look at the code, it is approximately 28 kilobytes. It generates the 28 kilobytes, but it only used to do the small code. It only encrypts that small particular code. If you're going to, I compare two samples, sample 1, sample 2, they are actually the same encrypted file. Okay? But looking at this, sample 1, the first D word to decrypt, it decrypts this to this. This instruction set, it decrypts the second 4 bytes. This instructions, it decrypts the third 4 bytes, and then so on and so forth. I didn't do everything else. Okay. Comparing that to sample 2, earlier, the first 4 bytes is actually, okay, as long as this, the whole block, the whole square. Okay. And it decrypts the same thing. And this one is smaller compared to the first sample. Decrypts the second word, and this is now your third word. Okay. So comparing again, sample 1, and this is sample 2. This is the first 4 bytes. This is the second 4 bytes. Remember that sample 1 and sample 2, they are differently encrypted, but they are the same sample. This is now the third byte for sample 1, sample 2. Even the registers here are different. If you want to make a detection for this, do not make detections for those metamorphic algorithm. Okay, you have to make detection on this particular part. I have this another demo, wherein it actually shows you how the metamorphic code works. Okay, for some malware that has metamorphic algorithm, most of the time you try to look into the code, but it actually slows you down. But there is actually a trick wherein you can totally jump out of metamorphic algorithm. Not just for beer luck. You can, if you encounter a malware which is using a metamorphic algorithm, all you have to do is to, because you will feel it if you're analyzing, you will know that there's something going on, that you are actually analyzing a metamorphic malware. Okay? All you have to do is to go actually at the very end. You try to find the jump or the call outside the metamorphic code. Okay? At the very end, see, it's just decrypting. It will go on forever to decrypt your malware. Okay? It's only part of the malware. But at the end of every metamorphic algorithm, there is a jump or a call. All you have to do is to put a breakpoint at that particular jump or call. Even for UPX, for example, if you try to unpack UPX or FSG or whatever packer that packs the files, all you have to do is to look for that particular jump or call. It will exit, but once it jumps out, you have now a totally decrypted part of that particular code. Okay? So somewhere there, it will end up to the EAX. There is actually a certain call. See? If you can find the jump or the call after that very long, most of the time you cannot spot it at the very first look because it has a very long set of instructions. All you have to do is to browse from your debugger, look for this. But be careful because sometimes malware author knows that you're also doing that. They might insert so many calls and jumps, right? So the trick is just put breakpoints on everything and then close your eyes and then execute, right? And then that's it. Once it jumps out, okay, that's it. You now have your fully decrypted, that's only for the metamorphic, fully decrypted metamorphic or opcode. See, it's now the same location. Okay? Sometimes when I analyze a malware, I just close my eyes, hoping for the best. Press. If you're using OLI or Immunity Debugger, press F9. That's it. You're done. Customization. What if the metamorphic for Birlac is it only uses those sub instructions to create the. Let's now make it even harder for malware researchers. I think I'm not supposed to teach you how to do this, but let's try to do this. Okay, for example, for the white instructions, white colored instructions, they are the regular instructions. They are regular instructions for Birlac. Okay, this particular white instructions here, the mob, the sub, okay, this is responsible for decrypting the 4 bytes. Okay, first 4 bytes. So what we're going to do is to make this even harder to detect. Okay, we are going to include instructions that is actually not doing anything, like garbage code. We call it the garbage collection. Garbage code, it looks like a regular instructions, but it doesn't do anything. If you push EAX, you pop EAX, nothing's happening. Nothing's changing, right? If you add EAX with 1000, whatever is the value of EAX, adding it with 1000, and then subtract the same value, it won't touch EAX, right? That is what we call garbage collection. Even though they are executable, but it is irrelevant to the actual code. Okay, that is, so we just made that particular part longer and it will slow down again the researcher, which is me, supposed to be me. Don't listen to what I say just for the sake of the presentation. I'm not teaching you how to make a malware stronger. Okay, again, collecting this particular part, this is similar to the white instructions here. Okay, the same set of instructions. Okay, but if you put spaghetti code jumping all over the code, you can rearrange. Okay, so the instruction here is, the first instruction is mob ESI 6D442. Where is it? It's here. Mob EDX142A, it is somewhere here. Okay, but if you're going to put a jump somewhere, like spaghetti code, okay, going back and forth, you can actually rearrange these instructions, but it will still generate the same code. It will still generate the same 4 decrypted bytes. That is what we call spaghetti code. Right? Another one, NOP. You know NOP? Nothing to do. It doesn't do anything. But, okay, you can now skip for example, you're detecting this, and then you're supposed to look for the same set of instruction here. But if you put NOP with different numbers, for example, your first infection is 1,000 NOPs, another is 10 NOPs, so it's hard for us to actually monitor what's happening on the actual code, right? Nothing to do, NOPs. Okay? Another irrelevant loop instructions. If you put loop instructions in between those codes like this, it's nothing is happening, but you make your code longer. You make that code longer, but still it doesn't touch what the actual code is doing. Dummy loops. Okay? This particular code decrypts this, okay, using Birlach's Metamorphic Engine. Right? What if we now add the NOPs, the garbage code, the dummy loops, and so on and so forth? This is now what your malware looks like for the first 4 bytes. Okay? Or you can change it, you can make it separately or differently every time. Okay? It's now hard to detect. But of course, Metamorphic Engine, okay, if you have a metamorphic algorithm, the malware researcher, what he needs to do is he just go for the jump or the call. But looking at this, just what I'm saying earlier, that be careful with the jump or the call because it can be just a dummy loop, right? So that is now your new Metamorphic Engine. We just enhance Birlach. Okay, I think we should not do recording for this. I'm just kidding. Okay, that is now the end of our presentation. Another set of, okay, for conclusion, okay, we just did the Metamorphic Engine. Okay, for reversing, usually you have to do is set a breakpoint at the end of the Metamorphic algorithm. Try to copy as much as decrypted code as you want from the memory. Of course, you have to get patterns from the decrypted code for detection. And for cleaning, okay, all you have to do is to extract the host file. Sometimes Birlach also has some registry keys. And of course, you have to delete all malicious drop files. Okay? And that's it. Any question? So many audiences, too noisy. Cannot choose. Question? No? I think that's it. Thank you for coming.